Hi everyone, welcome to my YouTube channel. And today we are going to continue with the same session, same topic, that is singleton design pattern. We have already talked about singleton design pattern in my previous sessions, multiple sessions we have already done, and we have covered some of the important things. Today, I'm going to talk about one of the simplest way of creating a singleton design pattern, and basically the thread safe design pattern. Okay, so we have already implemented a thread safe design pattern where we have used locking mechanism, but C#, basically the Microsoft .NET, it provides a unique feature, whereas if you wanted to implement a singleton design pattern, thread safe singleton design pattern, we can implement this even without using any kind of locking mechanism and all those things, and it will make our code very much simpler and smaller, and it will still work, and it is going to be thread safe. Okay, so let's open Visual Studio and go do a walkthrough of the code, and this is going to be the easiest one, right? So just let me open Visual Studio. This is the same code that we had used till last session, right? This is my main method program under class program, and where we are trying to call multiple methods, which would be creating one object each, and all these three methods will be called in parallel, right? This we have already seen that by using this method parallel.invoke, we are able to call the parallel task. I mean to say, we are able to call all three methods at the same time, and we were also able to prove how my other singleton design pattern was not thread safe. Then we used locking, then we did double lock checking, right? And then we also talked about the sealed, right? So now we are going to talk about one of the simplest way of creating the thread safe singleton design pattern, right? So just I wanted to do a walkthrough of this, and it is going to be the same. There is no change. So here what I'm going to do is I have created a new class now named as singleton static read only. Okay. So we have actually, and for this time now we have started using sealed. As you know, we know that what is the use of sealed and why do we need to use sealed when we are creating a singleton design pattern, right? When we are implementing a singleton design pattern. Now, so it's public sealed class, and the name of the class that we have kept here is singleton static read only. Now, what is the change? Till now, what we were doing is we were doing like this: public static read only, and actually it was not read only till now. It was like public static singleton, my class name, and then my property name, and then we used to put null, right? So and then in place of this we used to have null, right? So now what we are doing is we have added one more keyword called read only. I hope you understand what is the use of the read only, right? So if you put read only, it means it can be instantiated only either here or within the constructor, but we cannot use or we cannot assign any value in this variable anywhere else, in any other method or in any other any other place. We cannot instantiate it or we cannot put any value into it, right? So what we are doing now is in the beginning of the class, like in the beginning itself, as it is a static member, I'm just initializing with the new object of this class, right? So as and when, and now if you go, I'll talk about this method later on, and what is the purpose why I'm adding. And now if you say, and then this is our private constructor, and then in this method get instance, we are just saying return instance. Why return instance? Because we have already instantiated, right? And then as we have already discussed, the same thing, if you wanted to implement, instead of having a method, we can also implement it using the property. So here also in the property case, also the name of my property here is instance, and it is returning just this instance variable, right? So we can use either one of them. You don't have to put both of the things when you are implementing a singleton design pattern. You can use any one. Either you create a method or you create a property, public property, right? So now what is happening here is, because it's a static member, right? So what happens is, as and when we give a reference of this class anytime for the first time, when as and when we give the reference of this class anywhere, right? Uh, uh, this variable will get instantiated, right? So we'll and then we'll have this done. So basically, some of the people will say it is a eager loading, or some person will say it is still lazy, or it is in between somewhere. It is kind of semi-lazy or something like that. We'll talk about eager loading and lazy loading in my next session, but in this session we'll concentrate on how this is working. And if you see here, this, as I said, this implementation we have not talked about earlier in my earlier session, because this feature that this static member, and this, after putting this read only, Microsoft .NET guarantees that this is going to be thread safe. It means not more than one client can instantiate this variable. Okay, because one, we have put read only, right? And then we have static. So this Microsoft .NET, our CLR itself guarantees that it is going to be thread safe. This is not available in any other language. That's why we have not talked about this. So if somebody who is not using .NET, no, they cannot go with this. This is not available in any other place. Okay. So now in .NET, if you wanted to implement singleton design pattern, and with a very small piece of code without using the locking mechanism and all, we can still do it. And this is the simplest way of doing it. Just have an instance variable, means have a variable of the same of this class type, whatever the class that you are declaring, and just instantiate it in the beginning. And then you have to have a private constructor. We know what is the purpose of this private, so that it cannot be inherited by anybody else, and somebody else also cannot do a new. They cannot create a. They cannot use new keyword to create an object. And then what we are doing is, we are creating a method called get instance, which will be returning the value. So and what I'm trying to tell is, this is going to be thread safe. So let's run it and then see. So what I'm going to do here is, anyway, I have commented it out. So the code remains the same, and we'll just run it and we'll see how does it work. Right? Hope it makes a sense to you. Let me run it and then we'll see what happens. Okay, so as I said, so if you see here, this is a parallel invoke we are using. We have used earlier also, when we didn't use locking and all, and at that time it was breaking, and we were able to see that it was able to call private constructor many time. But here, even if we have parallel tasks coming, right? Parallel, we have created parallel tasks. We have creating three objects at the same time, as 3 methods are getting called. But still, if you see, my private constructor is called only once. It means, right, even in the case of parallel requests coming in and trying to create the object, right, and .NET is able to maintain the thread safety here, and this constructor, this instantiation happens only once, right? And if you see here, S3, S1, and S2 objects got created, and this is coming from these 3 method calls. And then after that, I am again calling create first object, second object, and third object. This is what S1 has to be next. So in this way, if you see, by just writing one single line, we are able to implement a thread safe singleton design pattern. Let me run it one more time to make it clear. Right now, let me run it again. Right. So the same thing. We have only one. This class is calling this private constructor, or this program is calling this private constructor only once, though it is creating 3 objects, S1, S3, and S2, due to this parallel task invocation. And then a separate task, that's obvious that it will be called one by one, right? But still, no, I just try to see if even if I am creating the object one, or calling that method one more time, what is happening? Is it going to get any object or not? So if you see, the constructor is being called only once, so it means we could call this, we have only one of the 3, right? So now let's talk about the instantiation of it, right? So as it is in static, we all know that as and when any member, any static member, at any moment of time, we reference this class, right? if we wanted to use this class, we wanted to call any method, or if we wanted to instantiate any variable which is inside this class, right? All this instantiation will happen, right? So that is why I have done it here. So what I'm doing is I'm just calling this method just to see how, when the instantiation happens, right? So I've just called this method singleton static read only dot test. So this is my test method, right? Now let me run this program. So I'm just calling this method singleton static read only dot test, and this is my test method where I have written test method is called, right? Now press F5, and if you see here, first of all, this test method is called. This is what we have done here is, and after that, all these things are happening, right? So when we talk about the lazy loading and eager loading, we'll again come to this sample, and we'll again even we'll do a walkthrough of the earlier code also, and we'll see how lazy loading and eager loading was working earlier session, and what was that actually, whether it was eager loading, whether this was lazy loading, what it was, why we call it, right? And then we will also go ahead with the lazy instantiation example. Okay, that's all for now in this session, and we'll again meet in the next session with some more details about the singleton design pattern. Especially, we'll talk about the eager loading and the lazy loading. And first of all, before we talk about the eager loading and lazy loading, we'll talk about the lazy loading implementation in singleton design pattern, and then we'll talk about the plus and minus and the differences, similarities, and all those things in all our previous implementation. So thanks a lot for watching this video, and as I always request you all, when you are watching my video, please just don't watch, please try to implement it, because it's very simple. I normally give you a fair time, and normally I keep the window stopped, so that if you really wanted to write a code or type a code, you can actually go ahead and type a code as well. Apart from that, I'm going to upload all these videos in a common repository from where, all these programs, all these solution files, I'm going to upload in a common repository from where also you can go ahead and download it. All these links will be provided in the video, in the comment section. You can go ahead and download these videos from there also, so that you don't even have to type. But I would recommend it. I recommend that you go ahead and type, so that you can keep the things in your brain for a long time, right? Thanks a lot for watching this video, and see you again in the next video. Thank you.